Welcome everyone to OpenCV weekly webinar. I am Dr. Satya Malik, CEO of OpenCV. This week we have Mrinal Karveer, Nihar Bendre, and Ojas Savant joining us from Intel with a presentation about Intel Developer Cloud, how it can be used to optimize your artificial intelligence workflows on the latest and the greatest Intel hardware. It should be a treat. But first, with me, as always, is Phil Nelson, Director of Content and Creative at OpenCV. Phil produces the show, so if anything goes wrong, it is probably his fault.
Oh, you added the probably back in there. That was sweet of you. Yes, thank you, Satya. It is I once again, the co-host with the co-most, the second banana who is second to none. I am also your plus one and only. It's Mr. Nelson if you're nasty, but you can call me Phil, and I'm here to remind you of a few things we do every single week here on OpenCV Weekly Webinar, the first of which is a giveaway to you in the audience. Stay tuned for that. Later in the episode, you'll have a chance to answer a trivia question made up by me during the show to win an OpenCV course about mastering AI art generation, which is currently on Kickstarter. You can check that out by going to opencv.org/Kickstarter. We'll also be taking Q&A from you in the audience. So use the little Zoom Q&A button at the bottom of the screen, wherever, or the comment section, wherever you are watching, YouTube, Twitch, Twitter, LinkedIn, etc., etc. And we'll do our best to flow answers to that in the conversation as time permits. We'll also try to save time at the end of the show to answer questions we don't get to during the show. But before we get started, Satya, how's the campaign doing right now?
The campaign is doing great. It is like I'm selling some product because all the numbers are below a certain threshold, like the total money raised is 89,950 or something like that. Total number of backers are 900 something. It hasn't touched
982 is what I see
982. Here. So it looks like, product pricing or something like that.
999, yeah.
But it's great in the sense that, the main reason we do these Kickstarter campaigns is so that we can reduce the price. We haven't, there are some contractual agreements because of which we don't reduce the prices as often, but Kickstarter is allowed. So we do this Kickstarter campaigns. The second thing we are experimenting with this time is this very short courses, right? These courses are literally, you can spend over the weekend, maybe 3 days, you can complete a course and become very well versed with stable diffusion and all the things that you need for mastering AI art generation. So this is a new format that we are experimenting with. Very excited about it. And it's also reaching a much wider audience. As you can see that there are 1,000 people who have supported the course already, nearly 1,000 people. So yeah, very excited about this. And I'm having a blast. We have already started making the course. So I'm having a blast with just the experiments, some of the things that we put on LinkedIn and other social media. It's basically coming out of the course that we are creating. So it's been a lot of fun, awesome. including my meeting with President Biden and former President Trump.
Yes, I don't have that link pulled up. Let me, I'll try to splice that into the episode here. But yes, and the course, the Kickstarter campaign, just $29 is the low tier for that course. By far the most affordable OpenCV course we've ever done, and the shortest. Isn't that also true? Just a weekend or so. Yeah, invest in yourself this year, learn something new, or even just learn something to have fun with. I know that there's a lot of controversy around Stable Diffusion and AI, these kind of AI generative tools, but at the end of the day, they're just a lot of fun. And I think that regardless of what professional issues there may be with these tools, they are a lot of fun to play around with your friends and family. I know that over the holidays in December, me and my mom and my brothers and nephews and family sat around, hunched over the computer, just asking it to do dumb stuff with Stable Diffusion because it was just very fun. And you can do that too and get really good at it if you back this campaign. So you've got 19 days. You can check that out at opencv.org/Kickstarter.
Thank you. I also want to thank our sponsors, OpenCV.ai. OpenCV.ai is a consulting company which not only specializes in OpenCV, it actually specializes in anything related to computer vision. So it could be, OpenCV or PyTorch, TensorFlow, any kind of application which deals with the analysis of images and videos, deals with deployment on the edge. We optimize the models and everything, the whole 9 yards. And so, yeah, I just want to thank OpenCV.ai. So, people don't know, but many people don't know that OpenCV is directly supported from OpenCV.ai. So part of the revenue that OpenCV.ai generates goes to OpenCV to support the library, right? So
yeah. I mean, if you like seeing stuff like OpenCV weekly webinar and you like me being able to eat, go check out OpenCV.ai consulting, or don't if you don't like me eating. I don't know. I don't know what your deal is.
All right. So now we are ready. It's your show. Let's take it.
Thank you so much, Satyanful, for having us here today. We are very glad to be here. I am Renal, and I lead the engineering for Intel Developer Cloud for the Edge. I've been part of DevCloud since its inception, and I do whatever it takes to keep users of DevCloud happy. I also serve as ethical AI champion and provide clarity on responsible AI practices. Nihar, do you want to introduce yourself?
Yes, sure. Hi, good morning, everyone. My name is Nihar Bendre. I am a PhD graduate from University of Texas, San Antonio with specialization in computer vision, deep learning, and responsible AI. I'm part of Mrinal's team and work as an AI software solutions engineer. I work on developing solutions for customers and also help them support their development. And yeah, that's basically it. I'll pass back the baton to you, Mrinal.
Sure.
Welcome to the show, both of you.
Thank you so much. Yeah, and a shout out to Ojas as well, who is supporting us on the chat and is going to provide follow-up information and links as we proceed to the session.
Awesome. Thanks for making my job easier.
So today's session is continuation of episode number 82, where Meghna did a fantastic job at introducing the DevCloud. If you haven't already checked out, please go and check it out. I highly recommend it. So today we are going to start with a quick short recap of how DevCloud can help you in your journey towards developing solutions for the edge. And then we're going to talk about improving your productivity with code snippets, which are essentially blocks of code, commonly used templates that you can insert in your workflow and save a lot of time. And then also going to talk about AWS Cloud Connector that helps you to bring any of your pre-trained model from AWS SageMaker to the DevCloud for benchmarking on a variety of hardware configurations we have. And then Nihar will walk us through benchmarking on latest Intel hardware, the 4th gen Intel Xeon Scalable Processor, also known as the Sapphire Rapids, and then Intel Data Center GPU Flex series, also known as the Arctic Sound series. And we'll do a quick introduction of OpenVINO 2.0 API.
Awesome.
All right. So DevCloud was born with a vision to remove complexities for the developer. Our mission every day is to make sure that we make it very easy for our users to develop solutions at the edge. So what are some of the common problems we face as developers? First is lack of access to edge hardware. Life before DevCloud involved waiting more than 6 months for the hardware to be available. And since it involved physical access, you had very limited access to a limited set of nodes at any given point of time. So we solved that by giving you instant global access to the latest Intel hardware, ranging from Intel i5, 7, 8, 9 to the Xeon family of processors. And you can get that access very easily by registering at devcloud.intel.com/edge. You get an initial access for 120 days, which can be easily extended. The other problem that we face is dealing with complex software configurations. All of us can relate to struggling with complex software complications and with drivers and resolving all the dependencies, that we are exhausted by the time we actually get to our use case development. So we solve that on DevCloud by making sure that we have the right hardwares installed on the right drivers installed on the hardware. And the latest Intel software works out of the box, and we have taken care of all of the dependencies and have virtual environments for you ready that you can just kind of choose and install it on the hardware of your choice and get started with your use case. The third problem we face while we are on our journey to edge development is not knowing where to start. So to solve that problem, we have provided curated content that starts with learning, where if you're just starting out, we have samples and tutorials that you can go through and learn about the latest OpenVINO features. OpenVINO, by the way, is Intel's free library or toolkit to bring any model from another framework to Intel and optimize it for the Intel hardware. So we support OpenVINO out of the box. And then if you already have a use case developed, you can just import it to DevCloud and benchmark it on the tons of hardware configurations we have. And we always make it a point to support the latest hardware at a launch, so you get instant access to it. And we also support various optimization toolkits such as Deep Learning Workbench for you to optimize and visualize your optimizations. So in summary,
can I interrupt a little bit? I have this favorite, OpenVINO story. A few years back, we were working on this application for background removal, like a Zoom kind of application where you remove the background in real time. So the demands were, it had to be more than 30 frames a second, even on a browser. So the model was running on the browser. There were other models that were running on Intel hardware, etc. So there was one particular model which we got it to run at 10 frames a second. And then that was, I think, the first time we made OpenVINO our, part of our workflow. So we were at 10 frames a second and we wanted to optimize it. And we just ran it through OpenVINO, all the optimizations, etc. And suddenly, it's like almost free. There was no loss in accuracy, almost negligible loss in accuracy. And we got this thing running at 30 frames a second, right? So that was like, oh, we should always use this whenever using Intel hardware. It's a no-brainer, right? You spend, I don't know, not even an hour, 2 hours maybe with a little fiddling here and there, and you achieve this 2x, 3x speed up, which almost feels like free lunch.
Yes, thank you so much, Satya, for sharing that story. Definitely, yes. So just to kind of summarize, with DevCloud, you have a curated workflow that starts with tutorials, samples to help you learn about the latest OpenVINO features, followed by various tools to build your solutions with Jupyter Labs, OpenVINO, and container workflows. And then you have tons of hardware available to test, ranging from the processor family, ranging from Intel Core i5, 7, 9 to the latest Xeon family. And with the Intel provided tools and techniques for optimization. So I'm now going to switch to a quick demo mode to take you through a guided tour of code snippets.
Awesome. We need to get a sound effect. Note to self, we need to get a sound effect for Brave live demo.
Yes. All right. So when you log in to the DevCloud homepage, from here, using the Get Started, you can quickly get into our Jupyter Labs setup. And with Jupyter Labs, you are taken to the launcher. Launcher has many useful things that can help you get started very quickly. First is most used notebooks and tutorials. Second is featured tutorials. And the third one is samples. So we have more than 20 plus samples covering various demos, domains such as healthcare, security, various features of latest OpenVINO with the tiny YOLO v4, and then also with various samples across retail, such as people counter, store aisle monitor, shopper grace, and also a sample for industrial safety care detection. So please take advantage of these tutorials and samples to get started on your journey.
Yeah, one thing I like about these tutorials, etc., is, when you build a final product, maybe you will have to train your own model because, sometimes the situations are different. So you'll have to train your own model. But let's say you want to get something approved from your boss, right? It's a proof of concept kind of thing. Nothing is as fast as taking one of these examples, right, and starting it off. And then you can also sometimes people have this, oh, will I have to spend expensive GPU on inference and things like that? Then you can show clearly that, no, you don't have to spend expensive, it's not expensive hardware. You can run it on Intel CPUs. And that's a very good way to create a very quick demo, literally in a few hours, maybe a day. You can have a very convincing demo for your boss or whoever the stakeholders are, for a proof of concept kind of thing, right? And later on, of course, for a specific use case, you always have to train or modify the model. But knowing that something actually works, let's say the Tiny YOLO V4 works on this hardware at the speed, that just cuts your time to market quite substantially. You don't have to do that experiment. You already have examples out there for you to look at and try it out.
Yeah, incredibly powerful tool for de-risking a lot of methods for solving various problems.
Yeah. Thank you so much, Satya and Phil, for that insight. And yeah, we have a motto, working demo over PowerPoint. So definitely this will help provide you a good starting point. Yeah, and then we also have the virtual environments set up for you. So from here, you can choose any version of OpenVINO that you would like to try out. We also have TensorFlow and PyTorch integration with OpenVINO. All dependencies, all installed for you and set up. All you need to do is choose the notebook or the console and get started with your development. So now I'm going to launch our code snippet tutorial. So code snippets are small blocks of code that help you accelerate your development. And we have many such commonly used functions encapsulated into code snippets across latest OpenVINO LTS. We also have OpenCV code snippets, matplotlib, and then NumPy. So for this particular notebook, we are going to build an object detection sample with MobileNet SSD. So I'm going to use the latest OpenVINO. And here you can see that we have code snippets also numbered, so that it makes it very easy to just build a notebook or a sample application in just a few minutes. So here, I'm going to just install all of the dependencies needed. You don't have to remember these dependencies at all. So just kind of, yeah, you don't have to remember the dependencies at all. You can just kind of use this code snippet. Oh, sorry about that.
Don't worry, I'll edit that out. It'll be seamless.
Yeah. So yeah, here we are installing all our dependencies. The second step is to download the model.
So all this code runs on the dev cloud?
Yes, it runs on the dev cloud. It runs on something, right now, we are on something called as a development node. So with the development node here, it's just building the application. And then later in our workflow, we'll see how you can submit it to the edge nodes as a job. So yeah, in this step, we are downloading the model from Open Model Zoo. So with Intel provides a repository of the Intel optimized models that you can quickly integrate in your workflow. With the print all flag, you can also see the list of all of the models available here. And for our purposes, we have chosen MobileNet SSD, but you can, with this template, easily choose to the model of your choice. Now, step 3 is a graph visualization. This is an optional step, but it helps you see and visualize the layers of the model and also kind of understand what is the input format for this model. So step 4 is generating an intermediate representation. So intermediate representation is a platform agnostic optimization and it's essentially results in 2 files, one bin file and XML file. So bin file has all the model weights and the XML file is the representation of network topology. What you get with model optimizer is you just have to write once and it runs everywhere. So at runtime, when you just choose the hardware of your choice, it will choose the right plugin without you having to program it specifically. So Model Optimizer also offers a tons of other tools and flags for you to optimize for size and the execution time. So one example, Satya, I think you gave in one of your previous episodes is where you have used Model Optimizer to reduce the size of the model and then kind of make sure that it ran with FPS 16 and the speed of execution was also much faster.
Yeah. Just to give a little bit more color, OpenVINO has 2 kinds of optimizations. I'm speaking in broad terms. The first step is using the model optimizer, and what it does is, so you have a model, right? You trained it using PyTorch or TensorFlow, doesn't matter. You brought it to OpenVINO, and this model optimizer, when it runs on it, it can remove, all parts of the network are not useful when you're running inference. Some of them are not contributing to the final output. The weights could be 0 or something like that. And so Model Optimizer does these kinds of things like called pruning and quantization, where you prune part of the network. So let's say 25% of the network is gone. Now you have a model which is 25% smaller, but with the same level of accuracy because you have removed all this unnecessary parts of the network, which are essentially the weights are, they are not useful, they are 0. And the other thing could be that, okay, you can also quantize the model that you're using it for, 16 bits or which is, usually doesn't lead to any negligible loss of accuracy, right? So that is the software part. It doesn't matter which hardware you're going to run this thing on. The model optimizer, this file that it creates, called the intermediate representation, it is independent of which platform you're running on because the optimization has been done on the architecture of the model, right? It's independent of the hardware. And the second step is hardware specific, where, different hardware may have different, they may have different RAM, they may have different kind of, what is it called? Some of them have specialized processors for running deep learning jobs. They may have vector processors, etc. And Intel takes care of all of that, right? So you tell them what is the target hardware, and it's going to produce a model which is very specific to that hardware, and it utilizes all the good things about that model. And that's the second level of optimization that OpenVINO does for you. So that's just to give a bit of color to people who don't know the whole pipeline.
Yes, thank you so much, Satya. So the next step for us was to configure the input. Here we choose our input file. Optionally, we can also set the number of requests for async API, which is one of the modes of OpenVINO. And here in step number 6, we write a job file, which essentially sets up the environment for running on the edge node, and also provides the input to the file and the path for the model. So with this is the job file that actually gets run on the edge node. And step 7 is where you can easily see the available hardware. So here you can see we have various configuration of Intel hardware, again, from Core to Xeon family. So for our purposes, I am going to choose maybe, Raptor Lake. And in Raptor Lake also, you have two configurations, one with the CPU and the other with the integrated GPU. So I'll choose CPU. Then we can choose maybe Comet Lake. Here again, two configurations. I'll choose the CPU. And then maybe I'll choose a Xeon. So here you can see the status of your job. And once the jobs are done running, we can see the output and also the telemetry, and also plot the results to compare it with the jobs that are run across these different device families. So while this is running, let me also walk you through some of the other code snippets that we have. So let's look at OpenCV code snippets. OpenCV has been an integral part of AI development. There's tons of useful functions for image and video pre-processing, which are very essential in an inference pipeline. So here we provide readily available code snippets, even for image, just to see the attributes, read, write, plotting the image and displaying the image. And then for video capture, we have a snippet that captures frame by frame images from a video so that you can feed it to your inference pipeline. Another very useful snippet is convert color, because OpenCV is natively a BGR model. But when you come to OpenVINO inferencing, as well as some libraries like Matplotlib, the format that you need is RGB. So this convert color function easily helps you convert the format. We also have a lot of snippets for resizing, shaping, transpose, so that you can make sure that your image is pre-processed for the inference pipeline. Just as an example, the MobileNet SSD model that we are using here today takes the input in the format of 1 frame, 3 channels, and 300 by 300 resolution. So these functions can easily help you pre-process and get your image ready in that format. Next, we also have various code snippets for Matplotlib that help you plot different kind of graphs easily, histograms even, and then store them in the format of your choice. And these are the code snippets that we offer out of the box, but you can easily create one of yours by with this template. You can add different tags, you can name it, and if you would like, you can also use this edit function and change one of the code snippets that we have to modify it for your particular use case. So these jobs are still running, but I have a tutorial already pre-run. So maybe I can show you here. So once the jobs are run, you'll see a nice graph, and that kind of displays the inference time and frames per second. So here we can see, okay, the performance at Xeon is much better, the inference time is much less, and it also processes more number of frames in per second. So maybe for my use case, Xeon is the better choice, but I have to also correlate it with other factors. That's where telemetry comes into picture. So see here with telemetry, with FPS inference, we have also you can correlate it with CPU usage. GPU we are not using here for this particular hardware. We get to see here what's the average CPU utilization, average memory utilization, power utilization, the ambient temperature, and together this helps us make decision like which is the right hardware for our use case.
Even with different models, sometimes it is surprising that we have seen that depending on the hardware, a particular model which is bigger than some other model, it could still run faster than the smaller model, just the way things line up. So it's very important, not initially, but ultimately before deployment, when you're choosing the hardware or things like that, that you actually do this thorough analysis, because sometimes it's not that obvious, right? It is, you may feel that, oh, you chose a bigger model and therefore it should be slower. But when you actually run it on the hardware, when it goes through all the optimizations and everything, you may find no, it actually runs faster than what you thought was a smaller model. So these tests are extremely important, because it's sometimes you get these unintuitive results that would surprise you, but in terms of costs, that could be very substantial.
And it's also true that a larger model does not necessarily mean it will be more accurate for your use case.
Yeah.
Yes. Thank you so much, Satya and Phil, for that insight. I think we can switch gears, and I want to show you Cloud Storage Connector. So essentially, this capability allows us to take any model that is pre-trained on AWS SageMaker to import it on DevCloud, and we can benchmark it on all of the available hardware. And specifically for TensorFlow models, we also can boost its performance with just 2 lines of code. And Ojas, who is with here on the chat, has written an amazing blog that you can check out. And it has step-by-step, just a guided tour and a tutorial of how you can use the free tier of AWS SageMaker along with Kaggle dataset and build a model for predicting weather in Rome. Using the fine-tune, using the available models on SageMaker that you can fine-tune with the data. And once done, you can bring it on DevCloud. All you need is your AWS credentials, just the bucket name, access key, and secret. And you can import those models and some of the test images on to DevCloud. So here, for example, we can choose the model, the mobile net V2 model. And then from here, we can choose a couple of test images, and then we can just import. And this blog also has a template notebook that accompanies it, that has all of the code ready for you. Just kind of, you need to plug in the paths for your model and for the images. So here you can see easily imported. And this is the notebook that comes with the blog. And in the interest of time, I've already pre-run it. And here you can see with this just 2 lines of code, import OpenVINO_TensorFlow as OVTF and OVTF.enable, you are going to see a significant performance boost. So we have just kind of ran the model, made sure that it does the prediction. And then we have the code here to submit it to the edge node as before. And here is the visualization of the results. Here you can see that we have a boost in FPS. Higher is better with OpenVINO integration with TensorFlow, and latency, reduced latency with OpenVINO integration with TensorFlow with just 2 lines of code. So please go check out that blog. With that, Nihar, I'll hand it over to you to talk about benchmarking on latest Intel hardware.
All right, thank you.
Big performance boost there is, almost like a 50% increase in the frame rate and like a 35 or 40% boost in the inference. Tremendous.
All right, so let me take it further from there. So Mrinal covered most of the part of the hardware that we host. Like, there's a wide variety of hardware that we host on DevCloud with the CPUs, with the Core family, with the Xeon family, the cores ranging from i5, i7, i9, and all the way from 6th gen to the latest 13th gen, which is Raptor Lake. We also have Atom family. And then for any computer vision related stuff, we have accelerators as well as the vision accelerator and the MoVDS VPU as well. And so let me dive into a demo and show you how the benchmarking works for the different hardwares we provide. And this here you can see is, oh, sorry. Before that, let me work on the next slide, which is like, let me introduce the Sapphire Rapids, which is the 4th gen Intel Xeon Scalable processors. As you see, it comes in 3 variants, the platinum, gold, and silver. And here they are like the differentiating factors between the 3 are pointed out. One key thing I would like to point out here is the Intel AMX. So this was not there in its predecessor, the 3rd gen Intel Xeon. So what Intel AMX is, it's advanced matrix extension. So this is a new built-in accelerator that can improve performances, especially for deep learning and AI related workloads. And it is also useful in like work cases like natural language processing, recommendation engines, and also image recognition. So
And the reason it is important is because Elon Musk said that 99% of machine learning is dot products.
Yes.
I mean, then again, you know, based on what we've learned, it's unlikely that he would know. So,
well, there's a lot of, if you have a good matrix engine, vector engine, then you get huge performance boost. And that's what this AMX is, right?
Yes, correct. So let's see some numbers with a live demo. So here we are using this benchmark app program that we have. So a quick disclaimer, the numbers you may see here, these are for the benchmark app. For any personal workload, they may differ. But the flow of this diagram, the flow of this notebook is quite similar to what Mrinal showed earlier in the code snippets. We start with importing the dependencies. And then for here, we are using ResNet 50 model. Like I said, like Mrinal said, this is the open model zoo repository where there are like more than 100 of pre-trained models there. You can use any model in any framework format, say Cafe, TensorFlow, or even PyTorch. And you download the model. Again, you can view the model and in its graph. And here we use the model optimizer to convert it into 2 precisions, the floating point 16 and the floating point 32 precision. And after that, the process is the same. We create a job file. We use this benchmark app.py file, which is there. So if you have, if anyone wants to run their own code, they can just have their py file uploaded here, and then you can submit it to any of the edge nodes. So this is the hardware selector. Here we are just showcasing some of the latest and greatest hardware, but if you want to see the complete list of hardware, you can hit this link, or Ojas can share the link to our hardware page online. You can see here. So now we have the Sapphire Rapids 8480 processor here. So let me go ahead and submit the job. So I'm selecting the target architecture for it, CPU. I submit the job, and to compare it, we have also the 3rd gen Xeon processors. So I'm submitting this, like I'm submitting the job to the 3rd gen Xeon processor. While this is running, let me point it out that this benchmark app, it can be optimized for two activities. One is you can have a high throughput, or the second one is you can have low latency. So based on the use case and what you're trying to work on, you can decide whether you want high throughput or low latency. Here you can see we have gone for the throughput option, but it can be easily changed. And while you can see the status of this as well, and both of the jobs are done, and hitting this plot results button, you can easily view the results. And oh wow, look at that. That is a big difference between the two.
smokes.
Yes. Yeah, everyone is surprised seeing these numbers, and wow, like every time I see this, I say that I should get a Xeon for myself, but
That's great.
yes. And now let's move on to the second piece of Intel hardware that I want to discuss about. That is the data center GPU Flex. So this, up till now, Intel had a wide range of integrated GPUs, but this is first of its kind, where this is a discrete GPU, and it comes in two variants, the 170 and the 140. So these are the heavy lifters for your AI workload, and you can submit jobs to it written in the common AI frameworks like TensorFlow, PyTorch, OpenVINO, obviously, and it can be used for wide range of applications as well. So let's go to the live demo and see some numbers over there as well.
So this GPU Flex, this GPU that you're talking about, they are only for data centers, right? It's not, they are not available. But Intel does have a discrete GPU for consumers also, right?
Yeah.
Yes.
Yes.
Is it released in the US now?
Yes.
Okay. Okay. But that's not the one we are talking about, are we?
No, this is the data center, the server
Okay.
GPU.
Got it. Yeah.
Mm-hmm. So again, we are going through the benchmark file. We follow the same path of importing model. We use, again, ResNet 50. This can be changed easily to any other model in any other framework. And we use the model optimizer to convert it to floating point 16 and floating point 32 precision. We create the job file. Again, the benchmark app file is set to work with high throughput configuration. And then we have submitted the jobs to the GPU Flex 140, GPU Flex 170. And then to compare it with, we are submitting the jobs to some of the integrated GPUs as well. So to save time, I have pre-run this, but this is just click and run. Anyone can do it easily. So this is like we are submitting to 170, 140, and then we submit it to the UHD graphics 770, which is an iGPU integrated GPU, and then the XC graphics integrated GPU, and the UHD graphics integrated GPU, and like get ready to be shocked. So there you go.
Wow.
Look at this.
I tried to prepare myself and it was not enough.
Wow.
This looks like Burj Khalifa compared to the other. So there you see
Burj Khalifa versus a one-story building.
Yeah. Yeah. So this is the 170. It's a beast. You can have any and every workload over there, and it will, like, you will get better than expected experience results. And this is 140. Between the two, there's quite a bit of difference, but 140 also stands out compared to the integrated GPUs and the numbers that we are seeing here. So moving on from that, let me talk quickly about the OpenVINO 2.0 APIs. So basically, the reason behind having OpenVINO 2.0 APIs was to have a better organization of the OpenVINO and also to make migration from different frameworks to OpenVINO easier and better. So one example of that I would like to point out is in the 1.0 API versions, the model optimizer, it would not necessarily keep the same precision that it had for the non-OpenVINO framework. Say, if it was int 64, it won't necessarily after model optimizer be int 64. There were cases where there was change in layout, but now with OpenVINO 2.0 APIs, that is not the case. You can use it anyone. And those users who are already familiar with OpenVINO API, the inference pipeline, there is like minimum change to it, so you don't need to worry. And another thing, those who are used to and have their code in OpenVINO 1.0 APIs, you don't need to worry because this OpenVINO 2.0 APIs, they're backward compatible as well. So you can try them out and like modify your code as required. So let me walk through this tutorial. We explain what, like this is again a tutorial for object detection with the 2.0 APIs. So let me walk through the pipeline of 2.0 APIs. So basically the way it works is that first, oh, sorry. Yeah, here. So we start with creating a core object. So here we use IE is equal to core. If anyone who has worked with the 1.0 APIs, they know this was not IE, this was not core, this was inference engine. And then basically move on. For example, the change here to 1.0 API is instead of here in 2.0, we have read model, whereas in 1.0, it was read network. And these are some like fine changes that one can easily tweak and make their code working for 2.0 APIs. And for further understanding of this tutorial and to play and get your hands dirty, this tutorial is readily available. You can work with it. And thank you. I'd like to pass it back to Mrinal to summarize everything.
Yeah.
Thank you.
Yes. Do we have time for questions?
Yeah, we absolutely do. Yeah, thanks
do
so much.
Should we do the giveaway first so that people have time? Yeah.
Yeah, definitely. So, folks watching out there, if you're just joining us for the first time, or if you need a little reminder, one thing we do every single week here on OpenCV Weekly Webinar is give away something to you in the audience via trivia question. I am going to ask a trivia question from the presentation by our illustrious guests. And if you answer correctly, the first person to answer correctly in the Zoom chat will win the OpenCV Mastering AI Art Generation course when it is made available, I believe in, what was the date again, Satya?
May 1st, like it would be available on May 1st. Yeah.
All right, so you'll get access to the OpenCV Mastering AI Art Generation course when it launches on May 1st. So get ready to answer in the Zoom chat. If you have won in the last 2 months, please do not answer and give other people a chance to win. Earlier in this presentation, we learned a lot about the latest and greatest Intel hardware, including the 13th generation of Intel Core processors, which features speeds up to 6 gigahertz. What is the code name for that new generation of processors?
Can we answer?
No, audience only. I have a feeling you probably know. No, everyone's answering Xeon. It is not Xeon. It is not the answer we're looking for here. We're looking for the code name of the 13th generation of Intel Core processors. I'll give you a little, somebody down there is getting super close. You got half of it. Is 2 words. 2 words. First word from a very popular film franchise. The sometimes antagonists of a very popular film franchise. It involves dinosaurs. Hey, there we go. R. O'Carroll. Raptor Lake. Raptor Lake is the answer we were looking for there. Congratulations, R. O'Carroll. Please send 1 email to phil@opencv.org, and we'll make sure that you get access to the Mastering AI Art Generation course when it is made available in May. Congratulations. We've got a bunch of interesting questions here. The first of which, so I'm interested in this myself. What do you hear from people on the Intel Dev Cloud users? I know you spend a lot of time with them, just hearing stories, really seeing what they need, because that's a big part of the job when you build software like this. What do you hear most from them, from customers when they come back and they're surprised about something? What kind of blows their mind after they figure out the ins and outs?
I think what blows their minds is the ability to benchmark, frankly, because they have means to do their development on their local machine, right? But they don't have access to range of hardware to kind of, do that benchmarking. So whenever that first benchmarking is done, that graph that we see, the buildings, right? That's what blows their mind.
Yeah.
And the second one that blows their mind is the telemetry dashboard, right? Being able to see all of the other metrics like the utilization, the temperature, power utilization, clubbed with inference and the latency, that just blows their mind. Yeah. And we also have tons of solution briefs on the website that kind of outlines how people have used benchmarking in their use case, ranging from developing during the pandemic, developing a solution using just X-rays to build to predict whether someone is suffering from the virus or not. So we have tons of such solution briefs as well.
So Mrinal, how do
Yes.
people use the telemetry data? Is it that, okay, you're doing inference on a model, and if the utilization is not high, does it suggest that, oh, maybe if you try a different model which uses it better, right? Because the speed could be,
Yes.
first of all, there are two reasons it could be slow, right? One reason is that, oh, it just takes, there's a lot of computation going on. And the second one is that there is not enough utilization. The architecture is such that things are not correctly ordered. So you may want to choose a slightly different architecture, which has better utilization of resources. Is that how people use it, or other ways?
Yeah, there are other ways people can use it. One maybe example I'll walk through is benchmarking, maybe a smart cities application, right? We recently worked with one company, and for them to choose the right hardware, and they were looking to go off from the competition. So their use case was smart cities. So it was number of video streams that they can actually stream. So they had a workflow where they upped the number of streams, and then they saw that from the comparative hardware from the competition, what is the max throughput that they can get, right? So they upped the streams, they saw the data, and then it's a combination of many different things, right? So utilization is one aspect, that is what they are obviously aiming for. But when you look at examples like smart cities, you also have to keep an eye on power utilization, because there is cooling constraints.
Otherwise, the city is not that smart.
Yeah.
Right.
Yeah. So yes, yeah, that's how people usually use it. Yeah.
I have to ask this question, otherwise people will hate me for not asking difficult questions. How does it compare with, so the GPU that you showed us, what is the equivalent for NVIDIA, and how does it compare, the two things compare?
Honestly, it won't be an apple-to-apple comparison, because this GPU, it's right now hosted on DevCloud, and like due to some constraints, we cannot get NVIDIA GPUs on DevCloud, but it is like, it's right up their alley. So you can whatever you expect from NVIDIA, this GPU will be on par with it.
Yeah, some people specifically mentioned the A6000 from NVIDIA, and we're wondering how that compared to the 140 and 170 Intel Flex GPUs. Is there any info on that, or is it really just a resource constraint?
We don't comment on that. You can. We can't.
Okay.
Yes.
You can probably
you
can log on, you can get that hardware and test it out as well.
Sounds like maybe a great post for Learn OpenCV.
Yes.
Yeah.
Yeah, I might be getting an Intel GPU for testing. So we'll see.
Right on. Yeah. Gosh. Yeah. I mean, those are I think we covered most of the questions we got here. We're pushing up on 10 o'clock. Next week, our guest will be Rerun, the awesome data visualization and data set versioning tool. Satya, you've talked with the rerun team, haven't you? Would you like to tell the folks a little bit about what they can expect to see next week with the newly launched open source tool rerun?
Yeah, so it's a data visualization tool, or so basically it's a tool where you have, let's say you have a data. The best example I could think about was 3D data visualization, right? So you have this point cloud, and you have information about the cameras, etc. And you can use it's a very simple, easy to use API where you keep logging various things, and you can basically visualize your data. You can see the cameras, you can see the point cloud, and it's not just this. I mean, I like the 3D aspect of it, but it is not just for 3D. It is also, if you want to visualize your own data annotation, you can do that very easily. So we'll get the details in that one, but it's very exciting. For me, I think the 3D data visualization was very compelling, because you can see the cameras and you can see all the 3D data. But we can, when we'll see the demo, when we'll see the demo, we'll have a better idea of how it is also useful for data annotation visualization. It was just released. Unfortunately, I haven't got the chance to try it out, but
they just posted it on GitHub, I think last week. We mentioned it in the OpenCV newsletter. It just passed 1.4K stars on GitHub. Congratulations to the rerun team there. 46 forks. Go check them out. I just posted the link in the chat. I'll also put it in the show notes for today's episode. Thanks so much to our guests, Mrinal and Nihar. Great presentation. I think our audience always gets a lot of value out of these Intel presentations, especially around the dev cloud. It is such a extravagantly useful tool that people just get access to. So thanks so much for telling us about the latest and greatest with that.
And
Thank
just
you.
So people don't miss, it is completely free, right?
Yes.
Okay, still
Yeah.
free.
Yes.
Still free.
Still free. Yes. And I want to give a special shout out to my amazing team who does such a fabulous job at bringing exciting new features to the dev cloud and make the latest Intel hardware and software available at launch. So thank you.
Thank you.
Thank you.
I also want to quickly give a shout out to Brandon Gillis. He's been, many people know Brandon from, OpenCV AI Kit. We did 2 massive Kickstarter campaigns together, both crossed $1 million. So he's not well, and he's posted that on LinkedIn. So we all send him best wishes for a full recovery. And our best wishes. So I just wanted the community to know about it, just because he has posted it on LinkedIn. So he definitely wants more people to know about it. And he's done some fabulous research on long COVID and what he went through. Not just that, but also he has put together a very detailed document on all the various resources available. So I just thought that it would be good for us to share that information.
Yeah, Brandon and I have butted heads a few times over the years, but I genuinely hope that he recovers, fully and quickly. It's his post on LinkedIn was harrowing. I really hope that it's a short-lived thing that he can laugh about in a few years. Right. So yeah. Next week, join us for rerun. I think that's all we got for this week. Satya, anything else before we get out of here?
No, that is it. Thank you so much, the entire Intel team and Phil for organizing the show, and our fabulous audience. Thank you, guys.
Yeah, we will see you next time.
Thank you.
Thank you. Same bat time, same bat channel, 9 a.m. Thursday. We will see you next week. Take care of yourselves out there. Take care of somebody else if you can. Adios. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.